Main reason that we require Docker is to simply create a way to set up our software system so that we can work in conjunction with Lambda architecture or have a good data storage in the form of a key value pair or a graph database or a document storage to have a good data processing system, for example, Hadoop distributed file system, which is HDFS, and to also have a complete solution of our software from the top to bottom, like what libraries were used to create this ecosystem of the code to the versions of our software application. um, what this helps us to do is save money and time in terms of the fact that we can bundle the services that we provide. We can develop our system, develop this application on our laptop and then deploy on a server. And we can scale it to multiple servers later by using distributed services. And we can have this entire system set up on a single server that can host multiple systems so that there are no conflicts. Another reason why we require Docker is to create software distribution in a proper way, because installing on the same system, installing the libraries in multiple systems is painful. So Docker can allow us to fully describe and set up the same environment in multiple systems once it has been defined and described in good detail in one system. Um, so the general challenge that we receive in coding or that we encounter while coding is that there are four problems. One is dependency hell, which means that software packages keep on depending on different versions of different software packages, and that's why it becomes impossible or at least very difficult to update the application. Another thing is imprecise documentation, because modules of code are not used. Because the modules of code that we use are not commented properly and do not have enough explanation within the code. We also have code rot, which means that certain modules of code are not used continuously and hence they just keep on staying in the entire application without being used. And the fourth problem is that we face barriers in adopting the same application and then reusing it in newer ways. So, a solution to this particular problem is by using a workflow software, which means we go in a systemized way of developing our application, but it really slows down the entire development process. We can even work with a VM, like a virtual machine, but that's bad for reproducibility in different systems. So here is where Docker can really help us, because it provides a lightweight runtime and packaging tool that is built for existing components, like built from existing components of Linux. It helps us to develop a workflow and an ecosystem for our code development. So, for example, if you develop a project on a Mac system, upload it to GitHub, and like basically you're uploading the Docker image on GitHub, and then a Windows machine downloads the Docker image and already has a Docker system set up in his laptop. He will be able to run the project without having to reinstall all the libraries, packages, and specific versions of those libraries or packages. So Docker workflow consists of three components. So basically, they're like nested within each other. So I'll explain. So Dockerfile is a script which makes the system, like it creates the system of the Docker inside your computer. It creates an image which basically pertains to all the files in the system that you will be downloading. And once you execute an image, it is the executed form is called a container. So it has all the results of your operated thing. So a general parallel to this would be, consider Dockerfile to be the schema of a truck. Then the image is a ready-made truck, and an operating system, a container is an operating truck. So a few uses of Docker are that it can help us to bundle microservices. It can also help us to create an interactive command, have interactive commands, and it is a fully contained solution from top to bottom. The main difference between Docker and virtual machine is that a virtual machine has applications like a layer of application, its respective libraries and bins built on top of a guest operating system. And that guest operating itself is packaged inside a hypervisor. And that hypervisor sits on top of a host operating system. And that host operating system is built on a server. So it's something like server can be your laptop, and the host operating system on top of it is your Windows, for example, and then the hypervisor is VMware, the app which will run your guest OS, which can be Ubuntu, and then your applications and bins on top of it. So Docker basically creates images of those applications and bins on top of your Docker engine, which sits directly on top of your host operating system. So you skip the layer of hypervisor. Um, Now, why is Docker going to be very useful for us is that it helps us to solve the existing problems that we have with the coding. So when we focused on dependency hell, Docker solves this problem by creating Docker images. So you have all the files that you need from top to bottom, and you don't have to depend on different versions of files because your code runs fully sufficiently in these files that you have defined. You also used to face imprecise documentation, but with Dockerfile, you already contain the code for the libraries that you downloaded, so you have proper documentation. And you can run your test cases as well in Dockerfile, so even that can be stored. And when we talked about code rot, your Docker allows you to create image versions. So this is like a benefit of having a Docker image to store your entire application in.